Welcome to the deep dive. If you're looking to level up your game and automate tasks like a true self-respecting hacker or, a sharp Linux admin, then you're definitely in the right place.
Absolutely. We've got some great material here, and today we're diving deep into bash scripting.
Yeah, and it's really about how these, well, seemingly simple commands can build up into pretty powerful tools, especially for things like network scanning.
That's the plan. Start simple, build up, show you the ropes with practical examples.
Okay, so why bash? I mean, there are other shells, right?
Sure, but bash is just
Yeah.
everywhere. Linux, UnionIX, macOS, Kali Linux. It's almost always there. Super practical.
Right, it's the default on so many systems,
Yeah.
and it runs system commands plus its own built-in stuff.
Exactly. And those built-ins, like echo for just showing messages or read for grabbing user input, they're
Yeah.
surprisingly powerful when you combine them.
Okay, makes sense. So to actually write these scripts, you need a text editor, obviously.
Yep, anything that saves plain text works.
Mhm.
Phi, Vim, Emacs, Gedit, Kate,
Yeah.
even LeafPad. Your choice, really. Got it. So let's make our first script then. What's step one?
Okay, step one is the shebang. Sounds weird, I know.
Shebang.
Yeah, it's the very first line, hashtag botbinbash. That hash bang tells the system, hey, use the bash interpreter to run this script.
Okay. So hashtag binbash. Got it. That's the key to making it run as a bash script.
Precisely. You might see other shebangs, like for Perl or Python, but today, it's all bash.
Right. So after the shebang, we need it to actually do something. Our first mission, display hello hackers arise.
Easy peasy. We use the echo command for that. Just echo and then the text you want in double quotes.
So echo hello hackers arise.
Perfect.
Hmm.
And really good practice, especially starting out. Add comments.
Right. The line starting with a hashtag.
Exactly. They're just notes for humans. Your future self will thank you. The interpreter totally ignores them.
Good tip. So the whole script looks like shebang line, maybe a comment line like hashtag my first script and then the echo command.
That's it. Now save it. Let's call it Hello Hackers Arise. Maybe no extension for this one. Okay, saved. Can I just run it now? Like type Hello Hackers Arise?
Not quite.
Yeah.
See, Linux is careful about security. Just because you created a file doesn't mean it's allowed to run as a program yet. You need to give it execute permissions.
Ah, right. Permissions. That's the Tron command.
Got it. The simplest way is chmod plus x hello hackers arise. The plus x adds execute permission.
Okay. I've seen chmod 755 sometimes too. Is that related?
Yeah, that's the numeric way.
Yeah.
755 gives read write execute to you, the owner, and read execute to the group and others. Plus x is just a quicker way for this basic case.
Gotcha. So trod plus x, hello hackers arise. Done. Now how do I run it?
Now you run it from your current directory. You typed /, then the file name. So it's job hello hackers arise.
/y the y.
It tells the shell explicitly, look for this file right here in the current directory. It's a safety thing, prevents running the wrong command if there's something else with the same name somewhere else in your system's path. Good habit.
Okay. Hello hackers arise. Hit enter. And there it is. Hello hackers arise. Nice.
Your first script.
Yeah?
Pretty cool, huh?
Yeah, that's actually pretty satisfying. Okay, so basic output is done. What about making scripts more dynamic?
Right, that's where variables come in. Think of them as named boxes where you can store stuff, text, numbers, whatever.
So instead of fixed text, the script can use information that might change.
Exactly. And a common way to get that information is to ask the user for it.
Okay, how do we do that?
2 steps,
Yeah.
basically. First, you prompt the user using echo, like echo what is your name?
Makes sense, just like printing the message before.
Yep. Then you use the read command followed by a variable name. So rename will wait for the user to type something, hit enter, and whatever they typed gets stored in that variable called name.
Ah, okay. Echo to ask, read to store, so we could ask for their name and maybe what chapter they're on in Linux Basics for hackers.
Perfect example. You do. Echo what chapter you on. Then read chapter. Now you have 2 variables, name and chapter.
Cool, and how do I use the stuff in the variables, like in a welcome message?
Good question. You use the $. So if you want the value stored in a name variable, you write name.
Right, so the echo command would be something like echo welcome name to chapter of Linux Basics for hackers.
Exactly. See how you're mixing the fixed text strings with the name and chapter placeholders? Bash replaces those with the actual values when it runs the command.
Okay, that makes sense. $'s the key.
It really is. Now, when you save this script, maybe call it welcomescript.esh. That .esh extension isn't strictly required, but it's a really common convention. Helps everyone know it's a shell script.
Got it. Welcome script.esh. And I assume I needed chmade plus x this one too.
You bet. Every time you create a new script file, you got to make it executable. Then run it with welcome script.esh.
And it should ask me for my name, then the chapter, and then print the welcome message using what I typed.
That's exactly what should happen. It shows how you can make scripts interactive.
Okay, cool. Variables and input.check. Now, the source material starts talking about, well, more hackery stuff, using scripts for scanning.
Yeah, this is where we bridge the gap from basic scripting to more practical network exploration tools. This is fun stuff.
So we're looking at automating network tasks.
Right. And the tool for that in our source is Nmap. It's a beast, super powerful network scanner. Comes standard on Kali Linux, but you can install it anywhere.
Nmap. Okay. What's the basic idea?
The basic syntax is like Nmap scan type target IP. You can actually add a port to.
Scan type?
Yeah, Nmap can do lots of different scans. The source highlights the simplest, most reliable one first. The TCP Connect scan, you specify that with NACOST.
NACOST for TCP Connect. So to just see if a machine at, say, 192.168.181.1 is up and listening, I do Nmap NACOST 192, 192.1, and double 1 and 10.1.
Exactly. It'll try to connect to common ports on that IP.
What if I only care about one specific port, like MySQL's default port, 3306?
Easy. You add the add an FEP option. So Nmap NACHST 192.168.181.1 NACHP 3306. Got it. Okay, so Nmap is powerful manually. How do we script this? The source mentions that hacker Max Butler, right, Max Vision. He used scripts to find systems with a specific backdoor port open. We're going to do something similar, the simpler. Find systems on a local network running MySQL on port 3306.
So automating the Nmap scan for that specific port across a whole network range.
Exactly. Applying what we just learned, let's build MySQLscanner.sh. Starts with #.bimbash, maybe a comment explaining the goal.
Okay. And the core is the Nmap command, I guess?
Yep. It'll look something like this. Nmap NACHST 192.168.181.024 NACHP 3306 devnull-og MySQL scan. Let's break that down.
All right. -t is the TCT scan, 192.168.181.024. That 24 means the whole network range, right? Like 192.168.181.3.254.
Pretty much, yeah. 24 is CIDR notation for that common local network subnet. Your own network might be different, of course. You can check with ifconfig on Linux or ifconfig on Windows.
Okay. Then NACHO T3306 focuses on the MySQL port. What's devnull?
That's redirection. Sends the output somewhere. Devnull is like a black hole. It just discards the standard output. The stuff Nmap usually prints to the screen. Keeps the terminal clean.
Why do that?
Sometimes you only care about the results file, not the live output. It can make scripts seem a bit stealthier, though on a local network scan, it's less critical. Good practice, though.
Okay. And the last part, -OG, MySQL scan.
That's the important output part. -OG tells Nmap to save the output in a special greppable format to a file named MySQL scan. This format is designed to be easily searched with the grep command.
So we run Nmap, ignore the screen output, but save the useful stuff to MySQL scan. What next?
Next, we need to filter that MySQL scan file. We only want the lines that show an open port.
So grep.
Exactly. The next line in the script is cat MySQL scan grep open MySQL scan 2.
Ooh, okay. Cat MySQL scan just dumps the file contents, right?
Yep. Then the pipe sends that output directly into the grep open command. Grep filters it, keeping only lines containing the word open.
And MySQL scan 2 saves that filtered output to a new file, MySQL scan 2.
You got it. So MySQL scan 2 should only contain results for hosts where port 3306 was found open.
And the last line of the script.
Just cat MySQL scan 2 to display the final results on the screen.
Okay, so the whole flow is scan the network for port 3306, save greppable results, filter for open ports, save again, then show the final list.
That's the essence of it. Save it as MySQLscanner.esh, charmod plus exit, run it with .MySQLscanner.esh, and see what pops up on your network.
This is getting pretty cool, but what if I want to scan a different network or look for a different port? I have to edit the script every time.
Excellent point. That's the limitation of hard coding values.
Yeah.
The next logical step is to make it flexible using
user input, like we did with the welcome script.
Exactly. We prompt the user for the network range and the port number.
Okay, so you'd use echo to ask, like, enter starting IP and read first IP.
And maybe enter the last octet of the last IP. The source clarifies last octet, like the 101 and 192.168.1.101. Store that in last octp.
Right, and then enter port number and read port.
Perfect. You've got the input stored in first IP, last octave, and port. Now, how do you modify the Nmap command?
Okay, instead of 192.168.181.024, we need to use the variables. How does Nmap take a range from variables?
It's quite clever. You can do first AP, last doc TP. So first AP is 192.168.1.1, and last doc TP is 101 NAP. Understands first IP, last doc TP as the range 192.168.1.1.101.
Ah, neat. Just a hyphen between the start IP and the last octet variable. And the port.
That's simpler. Just replace MySP3306 with non-IP port.
Right, using the $ again. So the command becomes nmap sat first AP last octet pp port defnull-og mysql spin.
Exactly. The rest of the script, the grep filtering, saving to MySQL scan2, and cat MySQL scan2 stays the same.
So now if I save this as, say, MySQL Scanner Advanced, chmon plus exit, and run MySQL Scanner Advanced.
It'll prompt you for the start IP, the end octet, and the port before it runs the scan. Much more flexible.
That's a significant improvement. Shows how variables really open things up.
Absolutely. It turns a specific tool into a more general-purpose scanner.
Okay, we've covered quite a bit. Basic scripts, variables, input, and now a practical scanning script. Before we wrap up, the source mentioned other built-in bash commands.
Yeah, bash has loads of them. We've used echo and red a lot, but there's also cd to change directory, pwd to see where you are, exit to stop a script. The source has a table 8.1 with a bunch more. Definitely worth exploring that list.
Good to know there's more power built right in. Okay, so wrapping this up, scripting seems pretty essential.
Oh, it's fundamental.
Yeah.
Automating tasks saves so much time and effort. Even these relatively simple bash examples show the potential.
Yeah, you can see how this builds a foundation for maybe more complex stuff later, like Python scripting, which the source hints at for Chapter 17.
Definitely. Bash is often the first step into that bigger world of automation.
So a final thought for our listeners, maybe think about how you could adapt these ideas.
Exactly. Take this scanner concept. What other services could you look for? Maybe Microsoft SQL Server. That often runs on port 1433.
Ah, so you could modify the advanced scanner, feed it the right IP range and port 1433, and look for MS SQL servers.
Precisely. The point is to take these building blocks, understand them, and then start thinking creatively about how you can apply them to automate things you care about. Experiment. That's the best way to learn.